All right, this is just gonna be a quick video in case people are confused by pH. So I'm gonna draw a little pH scale here on the piece of paper. We've got 0 to 14, smack dab in the middle. We've got 7. 7 is neutral. What makes something neutral is it has the same number of hydrogen ions. So when I write H+, those refer to hydrogen ions. If the number of them is the same as the number of hydroxide ions, OH-, then that means it's neutral. Anything to the left of 7 is a base, is an acid, and anything to the right of 7 is a base. Now, to avoid what I just did there with mixing them up, here's what I want to tell you. A comes before B in the alphabet, just like 0 comes before 14 in the number line. So that should help make sure, even if like what just happened to me, if you're starting to mess up, you quickly can correct yourself because you're like, wait, that's not right. A first, then B. So when you got the number line, when we have 1, 2, 3, 4, 5, 6, all of those numbers are acids from 0 up to 6, actually even up to 6.9999999 repeating, meaning as long as it's not 7, it's an acid. Then when we go 8, 9, 10, 11, 12, 13, up to 14, all those numbers are bases. Even 7.0001 is slightly basic. To be an acid means you donate hydrogen ions. So as you move in this direction, you're increasing in the number of hydrogen ions. So they have more hydrogen ions than they do hydroxide ions. However, when you move to the base side of things, they have less hydrogen ions and more hydroxide ions. So what you have to understand is between each number, it's not just a number of a difference of 1, but pH is logarithmic. So if I redraw my whole number line up at the top here, just to make it a little easier, because I know there's a lot written there. When I go from 0 to 14, with 7 in the middle of being neutral, if I compare something like an 8 to something like an 11, first off, I'm on my base side of things, which I don't think I wrote down here, that increases in hydroxide ions as I move to the stronger end, meaning you have the strongest bases here, you've got neutral here in the middle, and you've got the strong acids over here. The more you move away from 7, the stronger you are an acid or a base. So if I compare an 8 to 11, you might say, well, 8 to 9 is 1, 9 to 10 is 2, 10 to 11 is 3, and you might say it's 3 times stronger. No, that's not true. pH is a logarithmic scale, and that refers to the unit of 10. So a difference between an 8 and an 11, well, there's 10 difference between the 8 and the 9, 10 more between the 9 and the 10, and 10 more between the 10 and 11, but it's multiplied each time. So that means between an 8 and a 10 is 1,000-fold difference. Likewise, the same thing, the whole number scale goes the same. So if I go 5, 4, 3, let's say I'm comparing like a 3 to, let's say, a 1. That's not a 2-fold difference, even though it's 2 numbers in the number line. That's not a 20-fold difference. You don't add them. It's a 100-fold difference. So something that has a pH of 1 has 100 times more hydrogen ions than something with a pH of 3. Just like if we're moving in this direction, I'm going to refer to the other ion, hydroxide ions. A pH of something with a pH of 11 has 1,000 times more hydroxide ions than something with a pH of 8. So when we write out a sentence, I would say something like that with the pH of 3, which hopefully I have a substance name, or let me go based on the stronger one. Something with a pH of 1 has or contains 100 times more hydrogen ions than of 3. Or likewise, I can do a different statement over here. Something with a pH of 11 contains 1,000 times more hydroxide ions. Then, oops, can't see that. Then a pH of 8, which that's cutting off, so let me move my sentence. So pH of 11 contains 1,000 times more hydroxide ions than something with a pH of 8. So these two samples, because you can see it both now, I'll do that. This statement and this statement give an example of how we do problems, right? So for instance, let's do a problem together. If I asked you to compare a 5 versus a 6, pause the video and try that. Hopefully you concluded that something with a pH of 5 has 10 times more hydrogen ions than a pH of 6, because it's more acidic, so we'd refer to hydrogen ions. I could say something like the 6 has 10 times less hydrogen ions than the 5, or 10 times more hydroxide ions than a 5 as an alternative. But I like to just kind of keep it easy, especially when people are learning. What if we compared an 8 versus 14? So this is a little bit harder because it's a bigger number difference. You can pause if you need a moment. Go ahead and try it out. Think about it. 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13, 13 to 14. So in that case, 10, 10, 10, 10, 10, 10. You got to multiply them all together, each of the individual differences. One trick, you could say, well, what's 14 minus 8? Meaning how many times? 1, 2, 3, 4, 5, 6. Well, you could just do it this way, and you write your 3 zeros with a 1 in front. So that's another trick. It's just compare the two numbers and with basic subtraction and put all those as zeros, and then put a 1 in front of it. So in this case here, I could say the pH of 8, well, let's do the other end, sorry. The pH of 14 has million times more hydroxide ions than pH of 8. Hopefully you can see that all now, and hopefully this was helpful.